Yeah, again, welcome class. Today is still May the 18th, 2020. And we started the first lecture with non-parametric statistics, which gave us theoretical considerations. Now we are going to the practical part of it. And it's still Professor Dr. Rasheed Sanni, Associate Professor of Mathematics Education. He did pay tribute to Professor Arigbabu, who is mentor, academic father, and all of that. Professor Arigbabu, we really want to thank you for being part of this as well. Yeah, thank you, sir.
Thank you.
Yes, sir.
Thank you, sir.
It's so nice to have. It's so nice to have people that look up to you, like Professor Sanni is looking up to you. You are a great mentor to all of us. You are a great leader. You are a great scholar. We deeply appreciate you. So today is your day of joy, and I may, if I may want to ask all of us, because when the student, when the professor is seeing the student do so well, then he has to organize lunch. So when we finish from here, the reception of this lecture, the second lecture, is going to be at Tai Solarin University of Education. So all roads will lead to Tai Solarin University of Education for the reception of this great lecture. And then you can see the Secretary General of AVCNU, CVC, Professor Michael Favorode, who is locked down in the source in Ife. He has promised us that after the launch in Tai Solarin University of Education, we can come over to Ife, to have, top up. So that being said, let me welcome Professor Rasheed Sanni again to give us the second part of his lecture, which I have tinkered with to say non-parametric statistics, practical consideration. Over to you, Professor Sanni.
And welcome back. I'm sharing my screen right away so that we can have the slides. I'm going to slideshow. We all know me. Welcome back to the second phase, the practical section of this. We'll try to make it as practical oriented as possible. But before we go into it, it's important for us to look at what the objectives are being targeted in this second session. Like I said in the previous session, this second section is we're going to be looking at how to run and interpret man-with-new test, how to run and interpret Chisquare, and Chisquare test. These are the three things that we'll be focusing on. And one thing I decided to do is to, you realize that when I was talking about the advantages of non-parametric tests, I did say that they are actually much more easier to compute compared to parametric counterparts. Even though nobody does so any longer. What I mean by that is that we no longer try to use hand in computing. But if you see how we do this thing by hand, tendencies are that it is going to enhance better understanding of it. And the reason is we're going to be able to better appreciate why we can go for it when certain assumptions are not met. By the way, the man with the U test is also called the Wilcoxon rank sum test. And you're going to see where the rank sum comes to be when we look at the practical test of understanding of it. And it's used for testing the statistical significance of the difference between two groups by considering their ranks within all others. What do I mean by that? You have two groups, maybe boys and girls, and let's say there are 15 boys and there are 13 girls. That's 38. Sorry, that's 28. If you are interested in conducting Wilcoxon test or man with the U test, what you need to do is to pull all of these 28 together and rank them. I'm going to see that in a moment. Rank them. And what you will be testing the significance of is the different ranks. How many of these ranks, or which of these 28 ranks are male or boys? Which of these 28 ranks are girls? And that's what we are doing. As opposed to trying to establish what the the scores of boys are, the scores of girls are computing mean, and so on and so forth. Now, let's take an example. Assuming that our null hypothesis states that there is no statistically significant difference between the weights of male and female university athletes, and we collect the weights of these athletes. In the top row there, the first row has the number of the athletes, 1, 2, 3, 4 to 12, and we have 12 athletes that are female. We have only 10 athletes that are male, and these are their weights. We are interested in establishing what the statistical significance is of the difference between these weights. I'm going to have to stop this slide so that we can show to ourselves the different weights. It will take like 1 or 2 minutes for us to be able to appreciate very well what the what the test does for us on the background when we begin to use the SPSS to do it. Okay, here we are. What I've done is to actually put the males and the females together. That's how it's going to be appearing on our SPSS. What this means is that the first entry here is a male, and the weight of that person is 55.6. The next is a female, the weight is 74.3, and so on. And after doing that, we did the ranking of these weights. And the ranking is what we have on the third column, the last column there. For instance, the rank of this first male athlete is 2.5. But I'm sure the distinguished professor Kipkola has taken us through the ranking of data such as this. But the difference is that, and I'll tell you why. The difference is that usually when we have a data that looks like this and we want to rank, we tend to rank from the top to bottom. For instance, we're going to be saying that this 21 here, actually there should be 22. The person that is 22, this person, number 6 here, is first, and we rank him 1. In non-parametric statistics, it's the reverse order. And I did promise that I was going to tell you why. The reason is it's easier for us to say the person with higher numeric value is better than the person with lower numeric value. And what we tend to be doing in non-parametric statistics is use this rank to say that this group is better than that group. So if we rank from top to bottom and we sum up, we would likely be saying that the sum of rank that is less is the better group than the group with the higher sum of rank. And that's something the non-parametric statisticians do not want to do. So the ranking will begin from the least and it goes on and on to the highest. So if you look at the entire data here, this female in serial number 11, her weight is 55.4 and it is ranked 1. That is the least of all of the weights, and it's because of the reason I just explained. We rank from bottom to top, so that the higher we then get this, the higher sum then becomes the better one. Now we should observe that there are 12 female and there are 10 male. If we sum the ranks of the males, this is 13 plus 7, 20 plus 10, 30 plus 20, 50, 50 plus 18, 16, and so on. You're going to find that the sum of the ranks, total rank for male, is 107. If you do the same thing for female, you will find 146. I'm not going to waste our time on that because we're going to be having this slide. We can always review it at our own leisure. Okay, now what the statistics for Wilcoxon says that the minimum of these two sum of ranks is the test statistics. What do we mean by test statistics? When we conduct t-tests, let's say if you attempt to do it by hand, you find what the value of t is, what you call the calculated t. The equivalence of the calculated t is what we call the test statistic. The test statistics in this respect is the minimum of these two. And the minimum of these two is 107. So the test statistics for this recoxing test is 107. Now, we go, you can see that from the beginning to the time when we get the test statistics, the operation is just like a primary school arithmetic. Just rank, and then see which ranks are male, see which ranks are female, and sum them up. And the minimum of them is what we call the test statistics. We all know what test statistics are by now. There is also what we call the expected value, and that's something that tells us what the critical value should look like. I'm going to talk a little bit more about that later. For those of us that are in maths and other ones that are in the sciences, we know that the mathematical expectation is given by the number of groups into the smallest of the groups, which is N1, and then the sum of all the groups plus 1. That is the expectation of the critical value. If you evaluate that, you're going to have 115. So the expectation is 115. But what we observed, the expectation is 115. What we observed is 107. So what do we do? If the expectation were to be, if what we observed were 115, then we can immediately decide to say that there is significant difference between them and reject that null hypothesis if they are the same. But they are not the same. So the question is, how far or how close should both of these be for us to say the difference between them is significant and reject the null hypothesis, or to say the difference between them is not significant and do not reject the null hypothesis? That is when the table, there's a table for recoxing text. That's when we begin to use it. I'm going to stop sharing. This is what the excursion I want us to go through, and then go back to the presentation. Now, this is where we were, and we'll continue from that excursion in Microsoft Word. Okay, we observed from that brief excursion that the number of male is 10, the number of female is 12. We spoke about all of that, and we found that the expected value, the critical value, is 115. Okay, the test statistics, if the difference is not significant, that's what we expect. I explained that earlier. So what we do is to decide on whether to reject or not reject the hypothesis. We go to this table. If you click here, we're going to go to the table, but having to now have to go back and stop sharing, continue sharing, I won't do that. Once you get this, click on this, the recoxing table will be displayed for you, and that's the table that I've taken part of it to show us the conclusion for rejection or not rejection of this hypothesis, as we're going to see in the next slide. Now, the table looks like this. We see the top row. For us, our test is a two-tailed test. So we are here at the bottom, and our alpha value is 0.05. So we are here. Okay, if it was a two-tailed test and our alpha value is 0.2, then we'll be here. Okay. Now, what we are looking for and how to read the table is the M is the size of the smaller group, and that is 10. Remember, there are two groups. One has 10 participants, the other one has 12. So this M, the first column here, is the size of the smaller group, so that would be 10. And the N is the size of the larger group, that would be 12. So we are looking here. Now, to read the value, this table gives us an interval such that if our value lies within that interval, then the significance of the difference, there is a significant difference between them, and then we reject the null hypothesis. So, and the interval is the difference, this W. So the lower end of the interval is 84, and the upper end is 146. That's what I have here. So we say that the difference is significant if T lies outside of W. Okay, and now where is our T? Our T is 107. So T is within W. And so the difference between the ranks of the different participants, the male and female group, is not significant. Therefore, we do not reject the null hypothesis. Okay, it is that simple. And you will agree with me that just like we do in parametric statistics, the same procedure operates here, except that we use different tools. For instance, we use a different table here. But like I said earlier, nobody does analysis by hand again. All of these going to check tables have been overtaken by events. This is 21st century for God's sake. So I'm going to show us how to do this on SPSS. Of course, we did say that it's used for testing statistical significance of difference between two groups. And our example remains the same. No, the H0 says there is no statistically significant difference between the weights of male and female university athletes. Now, the first thing we should do is to load our SPSS, load our data on SPSS. This is the data that we looked at a short while ago in Microsoft Word. I'll be telling us what we'll be doing, and then we'll be seeing what the results will be once we do it. Now, we go usually, and in fact, always when we want to analyze in SPSS, we begin with analyze. From analyze, instead of looking for anything else, we go to non-parametric. Non-parametric, I just shorten it so that I can manage the space that I have. This is analyze. Under analyze, we look for non-parametric statistics, and then we look for legacy dialogues. Okay. There are two possibilities here. At this point, you can look for independent sample. Yes, you can look for independent sample. And I'm going to show you how to do that in a short while too. But I want to show us the legacy dialogues in non-parametric statistics. And from legacy dialogues, you can choose two independent samples because the samples are independent. Okay, and then we have this. Sorry. And then we have this. Remember when we have this, the weight will have been here in this box and the sex will have been there. So all we need to do is to recognize that the weight is the dependent variable and we put it in test variable, and then the gender or sex is the independent variable and we put it in the putting variable. There's actually something that the system will want us to do here. After putting the group variable here, it asks us to define the groups. If you click here, that is where you write one for, I think one is for male, no, one is for female, and then two is for male. Just write the figures that you used in coding, you write it there, and then you continue. Remember that we are computing man-Whitney U test, so we just say okay for this. Once we say okay, it takes us here, and these are the results. What do we need in these results? Okay, we need to observe that there are females, there are 12, males, there are 10 of them, and then the rank for male is, that is the mean of the rank. By the way, that is the mean of the rank. We have males having first, third, fifth, and so on, and then we sum them up and divide by 10. That is what we're going to get. The male rank is this, and the female rank is 10.7. And the sum of ranks is also here, is 145 and 107. Sorry, by the way, that's an error. This one was to have been 146, as you can see in the table here. Okay. But the important thing for us to make decision is what the man-Whitney U returns for us. The test statistics is 52, and that's what you see here, whereas the level of significance is 0.598. Okay. To conclude, how do we report it? Because it's important that we get how we report this thing very correctly. We say that there is no evidence to support statistical significance of the difference between the male and female athletes' weights. And we normally do, we put in brackets, T is equal to 52, N is 10, N1 is 10, N2 is 12, and P is greater than 0.0522. Therefore, we do not reject the null hypothesis. And that was actually the conclusion that we had when we compute the test by hand. Ladies and gentlemen, that is the end for man with the U test. You can see that it's also very easy, just like, especially when we are running it in SPSS, just like any other parametric test. Now we're going to chi-square. Chi-square is actually the most commonly used non-parametric statistics, but let's see what it is here too. So it's actually used for testing the statistical significance of independent of one event or variable over the other event or variable. Let's take this example. Online submission of assignments does not statistically significantly depend on internet stability. And that's actually a null hypothesis that we may want to look at in this class. If we are going to have a workshop, I was going to design a questionnaire or a form for all of us to complete, and then we see what that will turn out to be using chi-square on SPSS. But let's see how it goes. This is more not as theoretical as before, because we'll be seeing what we do in SPSS. Now, the first thing usually is to load our data on SPSS. And we really do not have to be talking about how to enter data. Quite a number of the distinguished Professor Dukola's videos have taught us about that. Two variables are of interest here, and that is online assignment submission, which we have asked whether there is an 100% assignment submission. And those that said yes is 1, those that said no is 2. Very simple question. Have you had 100% assignment submission? So this is one variable that will be of interest to us. The second variable of interest is internet stability. Do you have stable internet connectivity? Yes for 1, no for 2. So we have that data. And of course, as usual, we go analyze descriptive crosstabs. This is chi-square. The way to go is analyze, select descriptive, and the dialog box comes. From within the dialog box, we select crosstabs. And this is the stage for us. The first thing to do is to bring our data into the rows and columns. Some people will say that you can put anyone in row and the other one in column, but technically speaking, actually, the row should be for the dependent variable. The row should be for the dependent variable, while the column should be for the independent variable. So we're going to establish what the dependent variable is here. I think assignment submission will be the dependent variable, and it's dependent on internet connectivity. So we're going to drag assignment submission into the first to row, and the internet stability into column. And then we press OK. All right. In statistics, that's where okay, let me just go back to show you. We have these statistics here. Okay, so once we drag all of these there, we press statistics, and that's what we are seeing there. We have these after dragging them here, and then we press statistics. Once we click on statistics, we have this, and that's where we select chi-square. That's the only thing that we do here. After selecting chi-square, we select continue, and in continuing, we have this. Okay, to continue, we go back to, I think it's important that we show ourselves this, please. Okay, we show ourselves this. The first thing, when we select all of this, where we to select statistics is here. This is where we will select the second option here, is what we click to be able to select chi-square. The third option is what we click to be able to select other variables that we need to set for chi-square. Okay, this is so. Okay, this is what I was talking about. We see it on the first table that we see. And then we say, okay, we want the observed. The expected is not so important because we are not using hands to do it. We don't really need it. And then we click on row, we click on column, and then clicking on row and column is like clicking on, say, we want an analysis of the two variables that we have put in row and in column in the first instance, the first step that we did. And then the run cell will always automatically be selected. And if it is not selected, we need to select it because there is a need for us to do the cell counts. Okay. And then we click on continue. Once we click on OK, the result comes out. There are 3 tables in the results, and this is the first one. If you look at this, you will see that what is presented to us are just the descriptives. Okay, the total number of respondents is 150. The missing is, there is one missing. I don't understand that. I don't understand why, not that I don't understand it. It says that in the list of what we loaded onto SPSS, there is one missing value, and that percentage is 0.7%. So the percentage that we had all in all is 99.3%. Okay, but the real table that we need to do to take our decision are this table and the third one, this one. What do we need there? You will see these descriptives. What it says is that those people that says yes to internet connectivity, uninterrupted internet connection, and yes to submission of assignment are 88 out of the 150. Okay, those that say yes to assignment submission and no to connectivity are 46. 5 of them said yes to connectivity, no to assignment submission, and no are 11 in number. So you see that this table briefly summarizes what our data looks like. Whereas the second table here gives us the chi-square test results. Okay, and the entries that we need there are the Pearson's chi-square. The value for Pearson chi-square is 7.19, and the significance, what we might want to call the p-value, is 0.01. And that's all that we need here to take a decision. You agree with me that, in fact, what we really need to take a decision is the p-value, which is the significance, 0.007. But so 2 decimal places, that is 0.01. And in the next slide, we will see how we use all of this to do conclusion. In reporting this test, what we need to say is that chi-square analysis shows a statistically significant dependence of online assignment submission on stability of internet connection. And we put the values here, the statistics, not parameters, because we are using an example. The statistics says chi-square. Mind the way this is written, it is a symbol chi. Okay, and to write it, I see quite a number of people writing x squared. That symbol is chi, and the short form for it is to just write C in small character, highlight it and choose, instead of using whether area or times Roman, just choose symbol. Once you choose symbol on small letter C, it gives you the character that is representing chi-square, and the name of it is chi, and then the regular square, and we put this is the degree of freedom is 1, the number of respondents is 150, and the t-value, the test statistics is 7.19, the p-value is 0.1, which is less than 0.05. You know, our alpha level is always 0.05 in expression, and the test is a two-tailed test. Therefore, we reject the null hypothesis, and that is the end of the story for chi-square on SPSS. I was considering time, that's why I didn't want to do it using solving it by hand,
Sure.
But I don't really think it is necessary for us.
Sure.
The first one was to show us how simple it can be computing the test statistics for non-parametric tests. So we really don't need to do it for all of them. The third one that I did say that we're going to look at is the Puskawali's test. And we're going to set the, the Puskawali's test is the non-parametric equivalence of one-way analysis of variance. Okay, and we know that we use that when we have two or more, but some people will say more than two, but actually we actually can use it on two groups as well. Okay, and we are trying to test the statistical significance of their difference. Yeah, for example, we are looking at a null hypothesis that says there is no statistically significant difference in internet stability of people of different socioeconomic status. So what we are trying to look at here is whether socioeconomic status of people will be related to or will be dependent or will determine the internet stability, or put in another way, whether internet stability will be dependent on the status, socioeconomic status of our participants.
7 minutes more.
As usual, we load our... Sir?
7 minutes.
7, thank you, sir.
Yes.
As usual, we load our data on SPSS and we note the ones that we are interested in. We are interested in this one, no. Internet stability, which is this, that has 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 1, 1, and so on. And then socioeconomic status, which was measured on 3 levels, low, medium, and high, as usual. And again, we go analyze non-parametric independent sample. You will see that I chose not to go the legacy dialogue here. You also can go the legacy dialogue if you like. It's just that legacy dialogue is more conservative than this. You will always be coming to the same conclusion at the end of the day. I chose to do one using the legacy dialogue, the other one not using the legacy dialogue. So we just choose the independent sample, and this table comes up. It is important for us to note these database, objective, fields, and settings. Those are the 3 that will be setting appropriately for us to run the Puskawali's test. You will notice that objective has been selected there, which means that the one that is active now is objective. And in objective, it has, by default, selected automatically compare distribution across groups. Okay, that means that SPSS is going to look inwards to choose an appropriate test statistics for you, which is non-parametric. But because you know that what you want to do, or I know that what I want to do in this example is use Puskawali's test, I'm going to click on choose the automatic and choose custom or customize analysis, so that I'll be able to select the one that is of my choice. Okay, so we need to select customize and then say, after selecting customize, you don't say run, because you remember I said that you need to set the fields and you need to set the setting variables as appropriate. So the next thing is to select field after choosing customize. Let's see what happens next. Once we are in fields now, okay? And because we have chosen customize there, it will have automatically selected customize there. And then we need to bring our field variables there. The field variable is the dependent variable, so we drag the dependent variable, which is stability of internet there, and the groups is the socioeconomic variable. We drag it there. The difference between going parametric and going analysis, non-parametric, independent sample, and going analysis, non-parametric, legacy dialogue is that in legacy dialogue, this is going to ask you for prescription of the groups. What have you used to distinguish one group from the other? And you are going to just put 1, 2, and 3, because we use 1 for low, 2 for medium, and 3 for high socioeconomic status. But by and large, the report is going to be the same. So we have done objective, we have done fields. The next thing is to do settings. In settings, these are the things that we need to do. Set that we want to run Chisquare test. This is the customized test that we are choosing right from the workbook. Okay, so we say we prescribe Chisquare test, and then we say all pairwise. What all pairwise mean is that in case there is a significant difference and we are choosing to run what we call post hoc in parametric statistics, the pairwise chosen here is going to allow us to be able to see where the difference is coming from, which of the group is giving us that difference that we are experiencing. So it's important that we choose pairwise there. And once we did this, we have realized that we have done for objective, we have done field, and we have done settings, and we just click on run. That's why I said here that we should select run. Immediately we select run, we're going to have the results. Okay, this is the result. The interesting thing about Chisquare's test is that the result comes to us with a suggestion about what the null hypothesis should be, and that's what you see here. It also comes to us with the decision. The decision, do we reject or we do not reject the null hypothesis? In this respect, it is telling us that by this result, we are not to reject the null hypothesis, although it's using retain the null hypothesis. That's what we see here. And it also gives us the significance, what we want to call the p-value. Now, there is something important that we should look at, and I deliberately screenshot it together with that thing. If you stand in this box, the last cell here that says retain the null hypothesis, it says double click to activate. What that means is that if you double click there, you're going to have other tables that gives you other information about the test that you have just run. Okay, and those other tables are these two tables. Sorry, these two, one table and one chart. If you look at this chart, you will see that the low socioeconomic status, the middle socioeconomic status, the high socioeconomic status are common in terms of, I think this is their average rank. I'm not sure. In terms of the internet connectivity, they are the same. Okay, that's what this one says. And you get that just by double clicking on the information that you should retain the null hypothesis. And these are the things that we need to enter into our report. What are they actually? The test statistics is 2.19 and the p-value is 0.33. And then we can write our report. Chisquare's test shows that there is no statistically significant difference among internet stability of people of different socioeconomic status. And we put the values. T at 2, the degree of freedom is 2, the total number of participants is 150, and the test statistics is 2.19. Okay, the p-value is 0.33, which is greater than 0.05, two-sided test. Okay, this one uses two-sided test instead of saying two-sided test, but never mind that. They're talking about practically the same thing. Therefore, we do not reject the null hypothesis because the p-value is greater than 0.05. That is the story for that. And then we can summarize. We recall the non-parametric equivalence of the different parametric statistics that we commonly use in this second version of the session. And we also computed with the use test and interpreted the result using hand. We also computed the same test using SPSS and interpreted results. We ran Chisquare and Chisquare's test on SPSS and interpreted the results. Thank you so very much.
Oh, wonderful. Thank you so very much, Professor Rasheed Sanni, for that rich exposition. Now we have the floor open for comments or questions. If you want to take the floor, please so indicate. 3, starting with David. David, you have the floor.
To Professor Pro. I would like to know in which situation we can use Chisquare corrected. That we call Chisquare corrected.
Corrected. Okay, fine. Okay, so when can you use Chisquare corrected? Dr. Bugoma?
Thank you, Professor, for this wonderful presentation.
Yeah.
So my question is about, I want to ask, can we run Chisquare-Wallis test when we have more than two factors? For example, when we are testing internet stability against depending on socio-economic status and localization of participants.
Very good question. Very good question.
And the second was when we do the inverse, we take two independent variables against one dependent variable.
Yeah.
Are the tests still the same?
Very good question.
Sorry, the second question, I didn't get that. Your second question, please.
The second question is can we still use the Chisquare-Wallis test when we have two independent variable against one dependent variable? For example, we have to test. We have the dependent variable, which is x, and to test if the weight of participants can be influenced by the sex.
Very good.
At the same time, we want the solving of mathematics.
That was your first question. That was your first question. The second one is the one I didn't get.
No, in the first question, we have, for example, taking internet stability depending on socio-economic status and localization. For example, urban and rural. That was the first question.
Yes.
And the second question, we have loving mathematics depending on sex and weights of participants depend also on sex. I think there are two.
Oh, yes. Yes.
Thank you.
Roger.
Thank you, Professor, for the floor, and Dr. Rasheed Sanni for the lecture. I would like to know in which context we can use Chisquare without testing the independence.
Okay. All right. So that's it. For the benefits of our Anglophone class, when I go to Paris and they say we'll get to the hotel, they say we'll have Wi-Fi. So the Wi-Fi is Wi-Fi, the way we call it in Anglophone. So the chi-square is the k-square. So it's the same thing that they mean. So over to you, Professor Rasheed Sanni, to answer David, Bugoma, and Roger.
Okay. The question about chi-square corrected. See, all of these tests have corrected. Maybe not all of them. Quite a number of them have corrected and not corrected. The point about whether it is corrected or not corrected is it lies in the fact that whether, first of all, check whether they are the same or not. If they are comparable, I will always go for the non-corrected, because the non-corrected is the one that deals with your value exactly the way you put it there for them. If they are significantly different, that's when I'll begin to worry myself about which one do I use. And more often than not, at least in all cases that are brand, they seem to be comparable. So it never had occurred to me to check about whether when and whether one can use the corrected or not. But I promise you, before we have the workshop, I will look into it and we can talk about that during the workshop. The question that was raised by Bugoma was about two-factor, and I'm trying to summarize it now. When we're talking about analysis of variance, we have one-way analysis of variance, two or multi-way analysis of variance, and those are the number of dependent variables that we are interested in. Now, this one is one-way analysis of variance. There are non-parametric equivalents of two-way, three-way analysis of variance. But we didn't touch them here because of the constraint of time. If we have to do it, then we can bring them up at some other time. But they are basically about the number of factors or the number of dependent variables that we are interested in. This is just for one way. And the one way can be any one variable against the other. The dependent cannot be two if you want to use this one. The third question was asking whether we can use Chisquare without wanting to test independence. Chisquare is a test of independence. Although I've seen in some texts trying to call it, use it in testing relationship. And in this, I conclude within myself that it's a matter of semantics. Because if consider the example that we use, we try to look at the dependence of stability of stability of internet on socioeconomic status. Somebody might look at that and say what we are doing is trying to see the relationship between socioeconomic status and stability of internet in that place. So in that respect, maybe that's what we are trying to find out, whether we can use it if we want to do the test of relationship. The technical word, if we want to use chi-squared, is independence. It's a test of independence. So if you want to relate what you are doing and say, yes, in the end, it's giving me an what relationship that exists between the two variables, want to, because of that, call it variable, so be it. But the technical word for it is independent. So by that, we will say that you only would be using chi-square if you are testing independence. But bear in mind this explanation that I just gave. Thank you very much.
Thank you so very much, Professor Rasheed Sanni, for that explanation and for the very wonderful lecture. Now that brings us to the end of today's event. And I summarize by saying that we had a very good introductory part. That's the first part in lecture 1. And in lecture 2, we'll walk through the practical part. Actually, theory of practicals, because we're going to have a hands-on workshop sometime after the mid-semester break. I would like to join Professor Rasheed Sanni in letting Bugoma know that, you see, we have one way and over. Just like he said, we have one way. You have one-way Chisquare wireless. You also have two-way Chisquare wireless. We have the same thing. You see, as I mentioned in one of the sessions, that the parametric people are just waiting on the side, just waiting. When you have been, in quotes now, messed up by the parametric side, they are there to take you. So whatever you desire, they are there. They are the equivalent things that can help you out. That's what Professor Sanni has told us about. So whether if you have two independent variables, or if you have two factors situation, then you have a two-way Chisquare wireless, and it goes on like that. I've not really checked about the multivariate analysis of variance. So you have 3 dependent variables coming together. I've not really checked what we have as the non-parametric equivalent, but usually you have the parametric equivalent standing on the side. So very well done, everybody. By way of announcement, for tomorrow, we're going to have a course. That course is actually okay, that's fine. It's going to be interesting. I can see David. Yes. Okay, I'm told that today is your birthday, so many happy returns. I've just been flagged. That's your birthday. Many happy returns. But don't worry yourself. We are going to Professor Aribabu first in Ijagun. Then we'll go to Ife for the post-launch event, and then we'll come to you, okay. So many happy returns of the day. So talking about tomorrow, we're going to have this Professor Aribabu. Sir, are you ready for us? Because immediately I finish this announcement, we're coming over.
Yes, I'm ready.
Oh yes, sir. It's your son that has given the brilliant lecture, so you have to watch it.
Yeah, provided everybody will be here in the next 20 minutes.
20 minutes is too 20 minutes. Guys. We are there in about 2 minutes. That's not a problem, sir. That's not a problem. But don't let us don't use that as excuse. If by chance we're there the next 21 minutes, the null hypothesis is still valid. It's still not rejected. No type 1 error committed.
Yeah, in 2 minutes.
Oh, 2 minutes, exactly, sir. No type 1 error committed. All right, so we're going to have somebody from the UK, Professor Akim Ajongbadi. We're going to look at entrepreneurship, tomorrow on another course, ACE 814914. We're starting that one now. And he's after him, we're going to have Professor Martin Anetekai, who is the director of the LASU Entrepreneurship Center. Mind how I pronounce that word. I've not pronounced that word as entrepreneurship because that's not the correct pronunciation. The correct pronunciation is entrepreneurship. So entrepreneurship is happening, tomorrow. Somebody from the UK and somebody from the US. US is Professor Martins Anetekai. So it's going to be a great day. Now, we don't give any certificates because for Rasheed and for me and for anybody who has received one before from our center, because we are the ones now running the course. So how will you be given a certificate? So Rasheed, Sanni, no certificate for you. You are the people giving people the soup. So we just want to thank you when we meet everybody. If Professor Shabani is in the house, Professor Shabani, sir, I want to make a request. Professor Shabani, are you here? Maybe I slept. Then I'm going to take.
Yes, no, I'm here. I'm here.
Yes, sir. Yes, sir, Professor Shabani. We had as our first special guest for the month of April, the Honorable Minister of Education, former Honorable Minister of Education from Nigeria. We had as a special guest for May, this Honorable Minister of Education for Ghana. Now we're expecting our friend and brother and boss, the Honorable Minister of Higher Education and Scientific Research, to be our guest. Just let us know when it's convenient for him. And that's for June. Yeah, that's for June. He's going to be our June special guest. So all he needs to do is just interact with us for just 2 minutes, 2.5 minutes to talk to us, and then he can go. Tell him that before he comes, we will have gone to take a 2-unit course in French. So you can speak to us in French when he comes here.
Okay.
Yeah, please let him know. Share the videos of the previous honorable ministers. I can actually send you the links of the former honorable ministers that have addressed us. It's not a long one, just about maximum 3 minutes, just to greet us. All right, that's been said. I'm meeting everybody, and we are going to give a round of applause to Professor Rasheed Sanni for a job very well done. So that's it. Thank you very much. So until later.